All right, so here is another three-parter. So, where are my dividing lines going to go? -2 and a +6. You betcha. So, -2, +6. Okay, so when I go to graph the top portion here, it says f of x equals 5 when x is less than -2. All right, well, x is less than -2 over here. How do I graph f of x equals 5? Yes, it's just a horizontal line at 5. That's it. Now, once I hit my dotted line, will it be an open dot or a closed dot? Open in this case is correct. So a big old open dot there. So it's just a flat line there. Okay, good. Now, to graph this bar that's going to be in the middle, I want it to be 1/2 x minus 6. So I'm going to figure out where I start at -2. So take -2, plug it in. 1/2 times -2 is -1. What's -1 minus 6? -7. So I'm going to start at -7 with a closed dot or an open dot? Closed at -7. And then I just follow my slope of 1/2, right? Up 1 over 2. It should cross at -6, and lo and behold it does. Up 1 over 2, up 1 over 2, up 1 over 2. When I hit this other side, open or closed? Closed. Okay, and then just my last branch, I'm going to figure out my starting point by taking 6 and plugging it in. That's -12 plus 10 would be a -2. So at 6, I start at -2. Open or closed? Open. And then I just have to follow my slope. Down 2 over 1. Down 2 over 1. This problem just made me think of a good question I have for you. What if, when I had plugged in 6, what if the answer had come out to also be -3? It was -2, but what if it was the same as a dot I already had? What do you do?
Isn't it like an open circle?
There's already a closed circle.
Yeah, so if there's already a closed circle and I'm supposed to put an open circle on top of it, what happens?
Semi-circle.
It just stays closed. Because if it's at that same spot, that just means when x is 6, the answer would be -3, regardless of which one I'm on. So if you ever go to put a closed dot, an open dot on top of a closed, you just leave it closed. The other way around, if it's already open and I'm trying to put a closed dot on top of it, you close it. The only time it's going to stay open is if you're putting an open on top of an open. Then it stays open. But if either one of them is closed, it's closed. Is that still a function? So if you had something that looked like this, right? Let's just pretend. So if you had something, it went to here and it was closed, and then I put a closed on top of it, and then it went this way. Is that still a function? Yeah, because there's only one answer. When x is, I don't know, whatever this is, say it's 4, there's only one answer that's coming out. There's not two different answers. So as long as when I plug in one value for x, one value for y comes out, we're fine. It still passes the vertical line test. Does my graph pass the vertical line test? Yes, it does. Everything is fine. Whenever I hit a vertical line, I have an open over a close, so I don't overlap. That's fine. Okay. Did you graph this one correctly? Are they looking good? Yeah.
So I think that was just like kind of the same question I asked last time, but I don't get how you figured out your starting point for just the middle one. Like the
Oh.
other side that the middle one just seems weird because there's two different things.
Well, you could start out at either point, but it's much easier if you start at your left-hand point, your left-hand starting point. So you take your smaller number, -2, and plug it in. So 1/2 times -2 is -1. Negative 1 minus 6 is negative 7. So negative 2 comma negative 7 is my starting point.
So you just ignore the 6 for now? Or like
Yeah, because if I do ignore, which 6 are you talking about, this one?
Yeah.
Yeah, ignore it for now because I'm just figuring out where to start over here. And then once I have that point, I'm just going to follow my slope until I get over there. I don't actually have to do the math. You could, right? You could take 6 and plug it in. So that would be 3 minus 6 is negative 3. So 6 comma negative 3. Well, lo and behold, yeah, that is the point, but I didn't have to do that work. I just knew my slope is a half, so I just go up 1 over 2 until I run out of room. Okay, does this make sense? Are we all right? So we're going to look at one more different thing to